Thanks so much, Julian. And hello, everyone. Thanks so much for having me on today. I really like simple web technology. I'm going to always try to make my stacks simpler if possible. And today I kind of want to share some good practices around taking accessibility into our components. Very briefly about myself, I am a freelance accessibility and front-end consultant. I do this for lots of organizations like part of the Dutch government, the browser maker Mozilla. I was a while ago, and the W3C, where I currently work on some accessibility stuff. Now, I also write on my own blog. Please feel free to like and subscribe. There's RSS. I talk about HTML, CSS, JavaScript, accessibility, all of that stuff. If you want, I'm also on Twitter and things like that. But yeah, today we are here to chat about accessibility. And accessibility and component training. We'll start with the accessibility part, just to make sure that we're all on the same page. And then I will go into how we can kind of make that work in components. So accessibility, how do we define that? You may have heard different definitions. I like to say it is about ensuring that people with disabilities are able to use your website. Now, this translates also to that people with disabilities are able to buy your products. It is that people with disabilities can complete all of the steps that you have. If you have a service, or you are trying to get people to sign up to something, or to go through some kind of process. And it's also to ensure kind of that people with disabilities can use the service that you're building. That is what it is about. And you might be wondering by now who are people with disabilities. You may have a disability yourself, or you may have a relative, a neighbor, a friend. Many of us have disabilities. They can be visible, they can be hidden, but it's estimated that 1 in 5 people on the planet are disabled some way or another. That includes people who are blind, people who have vision impairments, who are deaf or maybe hard of hearing, people with physical disabilities, which might mean they can only use some parts of their body, or they may be in a wheelchair, people with cognitive disabilities. And then sometimes these disabilities are from birth. They could also be from disease, or from accident, or developed with age. So there's a very, very wide range of people. That's the point I'm trying to get across. It's a lot of different people that we're talking about when we are trying to make the web work for people with a disability. Now, statistics like these, they are a bit tricky because different countries and health organizations, they have different ways of measuring, different ways of defining what a disability is. Often we think of disability in terms of, are you prevented from doing a thing, or something like that. Now, the WHO, which this data is from, the World Health Organization, in their report on disability, they cite 2 different surveys. One of them says 50%, one says 20%. So the numbers can differ depending on who you ask, but the point is a lot of different people have a lot of different disabilities. And you can see that as well if you look at who is using your app and who is accessing accessibility features, as the Dutch web development consultancy Q42 did. They built a lot of apps for large Dutch brands. And they looked at the data of 1 million users, telemetry data of 1 million users of some top apps that they built. Now, they found that 43% of those users were using accessibility features. They were using accessibility features like dark mode, they were enlarging the screen, or setting the font size bigger, using higher contrast, bolding text, those sorts of features that are in most of our phones. That's a lot of people. Just to get the point across, you very likely do have lots of people who rely on accessibility features and who rely on, that your website is accessible. And this is important because people with disabilities, they face a lot of barriers on the web, even for simple tasks, like when they're trying to transfer money, when they're making a vaccine appointment, which many of us will hopefully have done recently. And it is really important that we have some ways to smash those barriers, that we really ensure that everyone can do these simple things, and everything beyond that, really. We cannot have a web where people with disabilities face barriers. That's not right. And I'm not the only one saying this. This is something that a lot of small organizations and large organizations are working actively on. I'll give you just one example. The computer maker Apple, they have something new recently introduced where executives get a 10% increase in their bonus payment if they stick to certain performance values, core values, including accessibility. So accessibility is part of their bonus structure. And many of the big tech companies, I mean, I'm naming Apple, but you could name Microsoft and Google. They are super innovative when they invent new technology. Apple has pioneered built-in screen readers, voice control. Microsoft has pioneered high contrast modes. Google has pioneered automated captions in YouTube and in the Chrome browser as well. So there's lots of different things that these different companies do. You're not the only one when you're trying to make your components accessible, right? And as I mentioned, the landscape of people with disabilities is huge, which is why it's useful that we have different ways of kind of embedding accessibility in our processes. One is to look at accessibility standards. They are built to take into account different disability standards like the WCAG standard, the Web Content Accessibility Guidelines. I won't go into the details too much today, but a lot of what you will be hearing will also be reflected in that standard. Best practices are important. There's a lot of people who have written about what are accessible ways of doing something versus inaccessible ways. And then user testing is a third pillar that is extremely important when you are trying to make accessible components. The standards can tell you one thing, but the most important thing is that you are sure that the users that use your product, just like you do regular user testing, that you also test with users with disabilities to make sure that your assumptions make sense and really work. Now let's talk about components. As I said, we want to be talking about those today. It's a bit of a contrast really between what was going on when I started out in development, which was about 15 years ago. I would be handed a Photoshop file or like a folder of Photoshop files, 10 pages, 10 files. It would really be kind of coding a page at a time. People really kind of thought in terms of pages. I can remember they would like print out these pages and hang them on the wall and stuff like that. Maybe some people still do that. But increasingly, we think about our code, about our design process, about our build process in terms of components and not really in terms of pages. Components really change the way we design, we develop, and we create for the web. And that was clear from Rob's talk, development in terms of components. But it's not just developers that do this. It's also people who design for the web. Their software has really kind of evolved around components nowadays. Process as well, the agile process and components, they are a really good match as well. Books like Design Systems from Alec Almatova, in which he goes to different large companies and talks about their design systems with them. Atomic Design from Brett Frost really helped inform some designers and developers in working in terms of components. But why do we do this? Why do we want to work with components? Well, I think reusability is one of the key components of that, right? We want to make some of our stuff reusable. If we do the work once, we want to repeat that work. And repeat what we've done there. And I think we can do that with accessibility as well. In fact, I think it's a really important thing that we take accessibility into account because we are kind of on the crossroads. We want to avoid repeating inaccessible patterns and we want to repeat accessible patterns. That's kind of the choice we're in. If we don't address accessibility, we might end up repeating inaccessible patterns. Whereas if we focus on accessibility and make sure, everything we do is accessible and has accessibility baked in at a basic level, because a lot of your accessibility will come after you've built a component. But the stuff you can take care of in the component, if you do that, then you're able to repeat accessible patterns, and that's really powerful. Then you're truly accelerating things for good or for worse. So as for the title of this presentation, accelerating accessibility with components, that's what you're doing. You're avoiding to repeat inaccessible patterns, and you're really going for repeating accessible patterns. And that's something you can do with any framework. You can pick any framework you like. You can do vanilla JavaScript or web components. You can choose to use Vue or Angular, React. It doesn't really matter. What really matters is the markup when it comes to accessibility and doing development for accessibility. The stuff you deal with in code is very often about markup. So when does markup come into play? Well, if you go to a website, if a user enters your URL and they follow a link to a website, their browser is going to request HTML. It's going to be responded to with HTML, this request. They are going to receive a bunch of markup. And from that, a tree is constructed, the DOM tree. I'm not telling you anything new, I don't think. But this DOM tree is kind of a reflection of our markup. It's doing lots of smart things happen when constructing this tree. If you've made a mistake, if you've closed the element wrong or something like that, is going to be taken care of, and the DOM tree is going to be a representation of your markup with some stuff fixed as well. If you want to get into detail about that, there's an awesome book by Simon Peters called Idiosyncrasy of the HTML Parser, which really goes into this, what happens when you send markup to a browser, and what is it going to do, and what is it able to do for you. Now, one thing that it does, and that not everyone knows that works with websites, is that one of the things browsers do, at least in 2021, they didn't used to, is that they also construct a second tree that is called the accessibility tree. Now, the accessibility tree contains information that is relevant for accessibility. It is things including names and roles and states. Names are things like, if you have a link that says click here, then click here will become the name of that link. When someone uses assistive technology, like a screen reader, the way that technology refers to the link is by saying, this is a link, click here. It is telling people about what this is for. We'll talk about it a bit more later as well. Roles are things like, what is this thing on the page? Am I looking at a button or a link or a checkbox or a menu? Or, what is this thing? And then states are obviously what state is this thing in, which is relevant for some elements, right? Some things might be expanded or disabled. They may be hidden, checked or unchecked, those sorts of things. So names, roles, and states are kind of the basic building stones of an accessibility tree. Now, as I mentioned before, some people with disabilities, they make use of assistive technologies in order to use their devices. For instance, someone who is blind may be using a screen reader, which is software that reads out everything that happens on the screen to the user so that they're able to interact with it. There's also text-to-speech software, screen magnifiers, voice control, where you kind of talk to a computer and then tell it to click on certain buttons. Now, these assistive technologies, one of the things that they have in common is that they need to know what is going on your screen. They need to understand what is happening. Now, they get this information from platform APIs that are built into the platform. So Microsoft has their own APIs, Apple does. There's some Linux ones and some mobile ones as well. And these APIs, they know everything that happens on the platform. They might know like what your start menu is, or if you have a browser, it might know how many tabs you have and whether they're open or not and active, and those sorts of things. So everything that happens on the platform. Yeah, when someone goes to your website, these platform APIs have never seen your website, or maybe potentially never seen your website. So how do they know what is going on your website? There might be loads of stuff on your website that they've never seen. Now, this is where, surprise, surprise, that accessibility tree comes in. It tells the platform APIs about everything that was going on the screen, names, roles, and states, as I mentioned before. So these things get communicated through platform APIs to those assistive technologies. And as I mentioned before, the accessibility tree is based off the DOM tree, which is based on our markup. So that is kind of where we come in as developers and where we can make that difference. If we provide the code that contains the roles or the states, that is going to be conveyed. And if we forget to do that, it is not going to be conveyed. So this is where we can make the difference between baking in something that's accessible rather than something that's inaccessible. So let's try and do that. Let's try to make sure that we repeat accessibility and not inaccessibility. And today I wanted to look at a couple of checks that you can do for each component. There are lots of checks you can do in terms of accessibility. I've tried to pick the ones that that I see a lot when I do audits of web pages, ones that are broken, quote unquote, on many different websites commonly, and also ones that you could put into a component to take care of them. There are also lots of accessibility issues that you can only deal with when you've put a bunch of components together and it becomes a page, and then you can kind of start working on them, or that are content-based or design-based. So these are the ones that are based on what you can do when you're coding up a component. So the things that you can check before you ship it. And one of the most important ones, I think, is that an accessible component needs to work without a mouse. And that's relevant for a wide range of different people. People who are blind, they cannot use a mouse because that requires eye-hand coordination. People who have low vision, they may have trouble tracking a mouse indicator on the screen. Sometimes they will use a larger one as well. It's something you can set up in the operating system settings. People with hand tremors or other physical disabilities, they may also have trouble using a mouse and find it easier to use a keyboard. So lots of different disabilities, they benefit from your interface working with just a keyboard. And the check that you want to do is, if something is clickable, if you can interact with it with a mouse, it should also work when you unplug your mouse and use your tab key. So anything that's clickable, anything that you could interact with, it needs to work with the tab, if you can click it or hover it. That's mostly important for things that are links or buttons or kind of controls. If you have a carousel or tabs, the kind of things that you use to switch those tabs or carousels, they all need to work with a keyboard. Something else that's important is that the active control is being highlighted. So when I'm using my tab key, as I am doing here in this browser, I am tabbing between different links. Now, these are 4 links that are on my website. I'm using my tab key, and you can see there's a black border drawn around the one that is currently focused. This is something that you need when you're using a keyboard to interact with this. Should you be using a mouse, then you can bring your mouse cursor to the link that you want to click on, and obviously you then know which link to click on. But if you don't have a mouse or you can't use one, you rely on this indication. It's a similar thing to when you're using a TV and you have one of those weird remote controls to kind of select what you want to watch tonight. Then you also need something that indicates what you're selecting as well. So it's a similar thing. It is important, and it is often broken. So this is one that you can embed in your component. Make sure to override the browser default with something that is more clear than the browser default, because some browsers don't have good defaults. And make it shine. You could animate it as well, or do something nice with it. But it is super important to be able to see it. So what's the current thing that I'm looking at? The other question to ask there is, does the order make sense? So do you have what the specification calls a logical, usable source order? So when you're pressing your tab key, are you not sent to the bottom of the page and then to the top and then to the middle and kind of going all over the place? Which is something that sometimes happens when you have a modal overlay and that's rendered kind of at the bottom of your DOM. And then suddenly you could have a weird source order. Something else that you want to make sure in your accessible components is that they have sufficient contrast. That's important for people with low vision conditions, such as colorblindness. They often find it difficult to read text with low contrast. It's also relevant for a bunch of people without disabilities, like you're outside in the sun, enjoying a drink and quickly checking what you're drinking, or maybe how your friends are doing. And you have low brightness, or you have the sun on your screen. Those sorts of conditions is also very helpful to have high contrast. This is something I won't talk too long about, because you can do this with tools. You can have an automated contrast checker that will check it for you. They don't catch all of your contrast problems, so also use your eyes. This can go wrong, for instance, if you have background images or gradients. The Firefox developer tools are particularly good at this. They take into account gradients in the background. Not all of the tools do. So make sure you are aware that your contrast is high enough, and there's a number that is in the specification and that these tools will use as well. So most of the major browsers will now tell you if there's an element that doesn't have enough contrast, it will show you. So make sure you don't get those bugs. They're fairly easy to fix unless you have brand colors that have low contrast, which I know one of the people behind this conference have had issues with. Orange on white can be a problem. You can also use this website called Who Can Use, which is a bit like Can I Use, but it's all about color issues and information about how well your colors work with common vision types, so different kinds of color blindness, for instance. Then something I wanted to mention is to name controls. I mentioned it before when we talked about the accessibility tree. It has names as one of the main features. It's going to give names to all of the major components that are in your accessibility tree. So things like all of the links and all of the buttons and all of the forms, that sort of stuff. There's a blog post by Holly Tuke, who has a blog called Life of a Blind Girl. And one of the posts he did there is 5 annoying things that she faces as a blind person every single day. And the first one she mentions is unlabeled links. She says unlabeled links make it much harder to navigate the website easily, quickly, and independently. This is annoying to her, and we need to make sure she doesn't get this annoyance by making sure everything is named. This is important to her, who is blind and uses a screen reader. It's also important for people with physical disabilities. They might be using voice recognition software to interact. I had this colleague who had a temporary disability where she had broken her arm. And she did come into work, but she had to kind of talk to her computer using voice control, which takes a bit of a learning curve, but she was able to do most of her work talking and kind of typing while talking, which is quite nice. And it's something that we see more commonly as well in different types of interfaces, like people talking to their different what I call like Siri and personal assistant type of stuff. Now let's look at how naming works. Let's say we have a very social network and we are working on the front-end development for them, and we're working on a component that is all about entering some story or something you're up to, and you have some characters left and you have a send button. Now let's focus on that send button and let's think about what kind of name this button will end up having. So let's say we have a button and it is currently empty, but it is a button, so it needs a name. When we code it, we probably will be using a button element. It is the best element for coding buttons. If we have just a button element with no content inside of it, what we'll see is in the accessibility tree that it will get a role of button. That will get assigned to it just because that is kind of the default for the button element. Now it will also get an accessible name, but in this case it will get the accessible name of null, or in some browsers the empty string. And that's because there's no content inside of it. There's nothing that can give it a name. There will be when we put some text content inside of it. And this is my favorite way of naming buttons. It's just by putting content inside of it. It is the most straightforward and maybe the one that kind of makes most sense when you think about it. But there are other ways as well. There are other things that can contribute to a control's name. And if you study the accessibility tree closely, you will find that lots of things can actually give things names. For instance, if you stick an image inside of this button, let's say an image of an airplane, it is going to take that accessible name from the alternative text. So I have the word send in there, and I also have an image with an alternative text of airplane. Now my accessible name is send airplane, which may be quite confusing because it doesn't make sense out of context. Are we going to send the airplane somewhere, or what's the airplane bit about? It doesn't make much sense. So know that when you have an alternative text, it will be part of the name for this button. You could also have just that image, and in that case, the alternative text will be the only thing that's naming your control. A bit of a warning sign, right? If you have a link that only has an image inside of it, maybe your logo, be aware that the alternative text for that logo will be the thing that names your link. Now you can do other things as well to name controls. You can use ARIA, which is a bit of thing you can put on top of your markup that will give you a bit more options. For instance, you can have the ARIA label attribute. If you use that, it's going to override anything that's inside of the button. So now the accessible name, if we add ARIA label send it, the accessible name is going to be send it. So it's not going to be the airplane that's inside of the button. It's going to be ignored, and it will get overridden by the ARIA label. One more ARIA attribute that you can use is ARIA label by, which works a bit similarly, but it refers to a different element that you may have on your page. In this case, I have a span with an ID of H. The content is send, and I'm using ARIA label by equals H. So now I have an accessible name of send. So the thing here is you want to make sure that your component has useful names for all of your buttons, for all of your links, and for a bunch of other things too. If you want to read this at your own pace, I have a blog post called Naming Things to Improve Accessibility that goes into the details as well. Or you can look at the specification. There is a specification for this called the Accessible Name and Description Computation Spec. A bit of a mouthful. The summary is right here on this slide. There's 3 things that can give something a name. The text content inside of the control, like we just saw. ARIA label, if you have that, it will override the text content. Or ARIA label by will override either of those 2. So those are the 3 main naming methods that will affect things that are on your page and that need to have names. So what do you want to check if you are working on a component? One is there a name in the first place? Like, is it not the empty string or something? And what is that name? And then the second question to ask is that name meaningful? There are 3 tricks that you can apply. One is to use function, not form. So in the case of a button with an aeroplane inside of it, you want to name it send and not aeroplane, because send is a lot more useful. I met this blind user a while ago when I was testing a big news application, and she was telling me that she finds a lot of hamburgers on the web and she doesn't really understand what they're about. And that's due to people naming their buttons after the form and not the function. Because a better name for a hamburger button would be something like, open the navigation or something like that, whatever it does. The second tip is to make them concise. So don't put something like, this is a button, and if you click it, it's going to open a menu. But put something like open menu and keep it nice and simple. And lastly, don't need to add any roles inside of your name. So you don't need to call the send button. You just call it send. And the assistive technology is going to add the word button because it knows that it's a button. It will take that information from the role. Cool. Then something else that you can do to make more accessible components is to make sure that it allows for zoom. That's something that surprisingly often breaks as well. It's relevant for people who have low vision conditions, who use Zoom so that they can read the content. So there are many people that will zoom in their browser quite a bit. Some will do like 100 or 200%. Well, 100% is the default. They'll go to like 200% to make things bigger. Others may be using 400%. And 400% is the one that's in the WCAG standard. So if you want to comply with that, you want to make sure that everything works when you zoom up to 400%. And here's an example of it not working. What does it look like when it breaks? Well, it could be things like I have 2 texts and they overlap. So I have the text previous image and the text next image. And in this case, the text image and next overlap so that you cannot read either of them. I mean, I know what these say because I've coded it up, but the user will not, and that's confusing. So you want to make sure nothing like this happens and basically apply the principles of responsive design. Then accessible components also need to convey states. I mentioned before, they are part of the accessibility tree. There's names, there's roles, and there's states. And states are particularly relevant for people who use assistive technologies because those technologies will be using ARIA to provide a better UI. Think about things like, is this checked? Is it disabled, expanded, hidden, invalid, pressed, selected? So these are all different states that you can convey to assistive technologies by using ARIA attributes that correspond with them. And that way you can make sure that users can understand better what is going on in your interface. So, if a checkbox is checked, if they have agreed to the terms and conditions or something like that, they are able to actually know that information. In the case of checked, you can also use the standard input element for that. But if you're not using that, you want to make sure that there is the ARIA in place to replace that. Now, the last user preference, the last accessible component that method that I want to talk about is to honor your users' preferences. And that's kind of a common theme throughout accessibility. It is important to realize that your users may be using different settings. They may be using a small device or a large device, or they may be zoomed in, or in fact, they may be using light mode or dark mode. And that's something that you can code for and that you can try and solve at the component level, especially if you're doing things like theming. So people with low vision benefit from this. They may be using a high contrast mode or some kind of forced color mode. Now, in terms of different color preferences, there are two things that the specification distinguishes between. One is preferred color schemes. So that's things like I want to use dark mode or I want to use light mode. And there's forced color palettes, which are things like the dark mode that is, or the high contrast mode that is in Windows. And there's a bunch of other modes that Windows has where you can say, I prefer these kinds of colors. Preferred color schemes are things that you can code for. So you can use a media query in CSS and then define some colors that you like. When it comes to forced color palettes, the browser or the operating system is actually going to force some colors onto you or onto your interface. So you've designed an interface, the browser is going to break it or make it different by applying different colors. And that's not a bad thing. It is something that users need and something that helps your users. So don't worry about it too much and make sure you test with it to make sure that nothing breaks again. Some of the properties that are changed by browsers when users are using these kinds of color modes are the color property, border color, background color, outline color, and a few others. They're in the color adjust specification, and I'll be sharing the links after this presentation so you can look at them at your own pace. But there's a bunch of different properties, that's the point, that can change by these color modes. So kind of be prepared for that. Be prepared that these colors may end up having different colors on the user screen. You cannot do anything about it, just like you cannot do anything about them accessing your site on their phone or on a black and white screen if they're using a Kindle or something weird like that. This could happen and you have no control over it. The only thing you can do is kind of try to make sure that your interface is robust enough to kind of deal with those changes. There are also properties that can be reset by these color modes. An example of that is box shadow, text shadow, and the background image, which means that you won't have these things. Even if you set them, if the user turns on their high contrast mode, these properties are going to be reset. So something like box shadow will now be set to none. Now, this is relevant as well when you are using box shadows for your focus outlines, which some people do because they give a bit more flexibility. You want to make sure that the outline property is not set to none, but it's set to transparent, so that in case the high contrast mode is going to turn off the box shadow, the user will still have the outline color. Because the outline is also going to be changed. It is in that list of properties. The mode will make sure there is a visible outline in the color that works for the user. So make sure you don't set it to none, but you set it to transparent instead. If you're using SVG, something you can do is to make sure you're using current color wherever you can, especially if you're using icons that are only in one color. This is useful because current color will compute to the color of your text. And yeah, you want to make sure that that adapts if the dark mode is going to change your text color. An awesome blog post about this is by Melanie Richards and Alison Mayer. They write web developers can use new standards to style their content to force color modes like high contrast mode. And it goes into some of the gotchas as well. Now, before I let you go, I want to talk a little bit also about the future, or what may be the future. I want to discuss something that is called the accessibility object model. I talked about the accessibility tree, which is based on the DOM tree. And there is the document object model, which the DOM tree is using. The accessibility object model would be a JavaScript API that will let developers modify and look at this accessibility tree for a given HTML page. So it's kind of giving users or developers access to the accessibility layer in a similar way that service workers give developers access to the network layer, and Houdini give developers access to CSS layer or the style layer. So this will give you access to accessibility with JavaScript. That sounds pretty cool, I think. It will let you fill some gaps in ARIA. You can provide your own accessibility, and you can do some testing. And this is something that will give you a lot of power, but it also gives you a lot of responsibility because you will now need to do it all by yourself. You can use this to set semantics without markup. So if you've not written any markup, you can create elements in your JavaScript, like Rob was showing, and then you can set some of your properties, like the role and the disabled attribute, without having to put an attribute in there. And that avoids something that the AOM explainer calls sprouting. So you no longer have to add 5 attributes for accessibility. You can bake them into that element, which I think is pretty cool. Something else that you would be able to do with AOM is to set relationships without ID refs, which are things like when you have a form element and you set a label, you're using the for attribute and the ID attribute, and you make sure they're the same so that these elements correspond. These sorts of relationships also exist in a lot of ARIA. Like with ARIA controls, you can say this element controls that other element, or ARIA labeled by, like I showed before. These sorts of relationships you would also be able to set in JavaScript instead of with an attribute. Now, there was talk about some events coming from assistive technology and pop up in the browser, but there are serious privacy concerns because it would allow developers to know whether someone potentially has a disability, and that's something that they cannot at the moment because the DOM tree is like a proxy between the developer and the accessibility tree, and we kind of want to keep it that way, right? So yeah, that's important. Also goes for non-DOM trees or non-DOM nodes in the accessibility tree. You would be able to kind of make your own accessibility tree without having any markup. Relevant for things like a spreadsheet application that uses Canvas and doesn't have any DOM. You could do all of that in accessibility object model. But this is again something that would have complications, including privacy, because that might leak to the developer that someone has a disability, and that's not something we want to do as part of the web. That's all stuff that we need to consider when we introduce new APIs. And then the last thing they want to work on is make the accessibility tree readable in JavaScript. I think that's a really cool thing because that would allow you to do testing of accessibility properties inside of your tests. So that's cool. Now, recently in the news was that Google Docs is switching to Canvas-based rendering, and they are thinking about using AOM or some form of it to make up for the accessibility losses that obviously has. In that sense, they are sidelining the DOM. They are already doing that by kind of keeping their own sort of virtual DOM type of thing to make sure there are some things available to assistive technologies, but AOM could help them there. So that's something that there's some talk about, but important to know now is that AOM is not ready yet. It is still being worked on, and the interest is a bit different per browser. Some browser vendors are more excited than others, and some browsers haven't implemented it at all. And the other thing is that it's only for very advanced users. So if you are building something very specific, this might be fantastic for your use case, but in most cases, it's probably easier to use built-in elements that already have the accessibility stuff for you, or do your accessibility just with regular DOM. So that's all about the accessibility object model. I wanted to give you a quick summary before I let you go. So what I wanted you to take away today is that, we've got to build accessible components. I'm sure you'll agree, because so many people in the world have disabilities, and we need to make sure that at least the web works for them. And many companies do, so that's great. Join us. It is the markup that matters. A lot of what we do comes straight out of markup. So if you are hiring anyone, new developers, not only test their JavaScript knowledge, but also make sure you know about their markup knowledge, and make sure they understand HTML deeply. When you're training developers, don't send them on training for the latest framework, but maybe also train them for HTML knowledge, because it can make a huge difference for the accessibility of your end product. Then the things you can use: standards, best practices, and user tests. They work best combined. And then the things that you can consider when you're building components before shipping them is ensuring that your keyboard works, contrast is great, there are names for all of the controls, zoom doesn't break anything, states are conveyed, and user preferences are taken into account. So that's all for me now. And yeah, looking forward to maybe answer some questions in the Q&A.